Welcome once again to the YouTube channel of Mathematics Experts. If you are new to this channel, kindly hit the subscribe button, like this video, and make sure you share this video to your learning colleagues. Now, I got this question from a group, so I decided to make a video on it to explain. At least I got almost 10 questions, but I will explain 4 questions in this video. Okay, so in order for you to know more about integration, you need to be solving questions, solving questions. So if I solve these 4 questions for you, at least your brain will be open to adapt with the modus operandi of solving integral problem. Now, the first one is the integral from 1 to 27 of x to the power of 1 over 3 plus 2 divided by the cube root of x squared with respect to x. Now, how do we solve this? Whenever you are given an integral problem, the first thing you need to think of is, what substitution can I make that will cancel out something and change the whole variable into another variable totally? Now, somebody will think that, what if I say what if I say t equals to x to the power of 1 over 3? Because I'm trying to say that I want to re-express this thing. It's very complex and I can't easily solve it. Are you getting what I'm saying? So I need to find a kind of substitution that will work, and I will substitute and it will change all the terms. So for instance, now the terms that are in this integrand, are you with me? The integrand is the function, this is the integrand. All the terms in this integrand, they are s. So if I want to substitute, everything that is s should not be seen again, so that I'll be able to solve the problem easily. So what am I going to do? I'll say let t to be x to the 1 over 3 plus 2, right? This thing here, I want to let t to be equals to it. So my dt is now differentiating this one is 0. Okay, so we don't need that. Differentiating this will come down, we'll subtract 1 from it, it becomes 1 over 3 x to the power of 1 over 3 minus 1 with respect to x, right? Dt is now what? 1 over 3. Now this thing now, 3 minus 1, so 1 over 3 minus 1 is simply minus 2 over 3. 3 times 1 is what? 1 minus 3 all over 3, which is minus 2 over 3. So that's how it's minus 2 over 3. So this one is what? X raised to minus 2 over 3 dx. Now dt now is now what? This one is 1 over 3 times 1 over x raised to 2 over 3 dx. So that dt will be what? Dt will be 1 over 3 cube root of x squared with respect to x. Are you getting that now? So you multiply this by this to get our dx. So our dx is 3 cube root of x squared with respect to t, because I'm multiplying it here. So now I'll now come back into my integrand, my problem. Now note that 27 is for s, 1 also is for x, so I'm going to change the limit also. So this is what we have. So the t upper will be what? Will be the cube root of 27 plus 2, which is what? 3 plus 2, and that is 5. Then the t lower, because I'm using t, that's why I'm saying t upper and t lower, that'll be cube root of 1 plus what? Plus 2, which is what? Which is 3, because cube root of 1 is 1 and 1 plus 2 is 3. Now back to the integrand, it will be going from 3 to 5, from 3 to 5. Can you see that now? But my s to the 1 over 3 plus 2 is t, so I'm going to put t squared. Then this thing now, I write it back, which is the cube root of x squared. Then now note that dx is this, so I'll multiply by 3 cube root of x squared dt. So this cancel this. Can you see that now? And from 3 to 5 we have this 3. Let's bring it out. That's 3, and what? We put our t square here with respect to t. Can you see that? Please, I hope you are following. Now let us integrate this. This will become 3 times t raised to 2 plus 1 over 2 plus 1. Then it's going from 3 to what? To 5, right? So let's get our final answer. We get 3 times t cube over 3 going from 3 to 5. Now this is equals to 3 brackets. So I put 5 here. That's 5 cube over 3 minus 3 cube over 3. So this is equals to, you can open the bracket, so you get 5 cube minus 3 cube, because 3 multiplied by this, it is cleared out. So this is 125 minus 27. 5 times 5 is 25. 25 times 5 is 125. 3 times 3 is 9. 9 times 3 is 27. So that our final answer becomes 98. So this is the therefore the integral from 1 to 27 of x to the 1 over 3 plus 2 all squared, oh my god, over the cube root of x squared is equals to 98. So this is the answer to the first problem. So now we are going to be solving the second one. So here's the second question now. How do we solve this? Wow, this is a very, very interesting problem, but don't fear its appearance. You don't need to be afraid of its appearance. What we need to do is to use the trig identities. Now this sine cube x can be rewritten as something, okay? So we just need to use the trig identity. So how do we do this now? How do we do this? That's the question you need to ask. Now we need to decompose this sine cube. Note that it can be rewritten as the square root of cosine s times sine squared x, then multiply by sine x with respect to x. Okay, so we decompose it. Okay, now this sine squared x can be rewritten as something. Sine squared x plus cos squared x is equals to 1. Yes or no? Yes, that's absolutely true. So that sine squared x is equals to 1 minus cosine squared x. So we're gonna put this into the problem. So we have the integral of cosine x multiplied by 1 minus cos squared x, then sine x with respect to x. Now after this has been decomposed, you notice that this thing now is it can be easily solved. So what do? We say let t to be cosine x. The reason, now when you think of a substitution, always check, because if you want to substitute, you will see the future before trying to start it. So in substitution, we would have seen what it will yield to before we now start saying let it to be this. Because the reason why I'm saying this is because when I differentiate it, I'll get sine s, and the sign will cancel this sign here, and it will be easy for me to solve this. Do you get it now? So now what are we doing now? We now say the integral of square root of t times 1 minus t squared. Then I'm putting my sine x here. Now dt is negative sine x dx, so that our dx will be negative dt over sine x. So I'm going to put my dx here, which will be what? Minus dt over what? Over sine x. So this cancel this. The minus, I can bring it out. It becomes minus the integral of the square root of t times 1 minus t squared dt. You can see that this is now easy. Now what do? We change this to 1 over 2 minus the integral of t raised to 1 over 2 multiplied by 1 minus t squared dt. This is minus the integral. Now we open this. This is t raised to 1 over 2. Then minus t raised to 1 over 2 plus 2. This is indices. Okay. Now we have minus the integral of dt. So we can split it. So it is minus t raised to 1 over 2 dt. Then the minus here will affect this one. It becomes plus the integral of what? T raised to 2 times 2 is 4 plus 1. That's 5 over 2. Then dt. See, that's a trick I usually use. If they give me 1 plus 1 over 2, I don't need to be doing LCM. I'll just multiply this by 1. And I just multiply this by this 1 here and add this 1 here. It becomes 2 plus 1 over 2, which is 3 over 2. So I don't usually use all those LCM stuff. I use the trick there. So please, I hope we are following. Now, so how do we do this now? Now, we can integrate this. it becomes minus t raised to 1 over 2 plus 1 over 1 over 2 plus 1, then plus t raised to 5 over 2 plus 1 over 5 over 2 plus 1, then plus the constant of integration. Now this one also is what? Minus t raised to 3 over 2 over 3 over 2, right? Then plus t raised to what? 2 times 1 is 2, then plus 2 plus 5 is 7 over 2, all over 7 over 2 plus the constant of integration. Now we can change this, it becomes minus 2t raised to 3 over 2 over 3. That's changing it to a single fraction. Then plus 2 raised to t raised to 7 over 2, all over what? All over 7. Are you getting it? Then always add your constant. That thing carries mark. Okay. Now, so what do we do now? What do we do? Since we have gotten, we know our t. We didn't started with t. Do you get? We did not start with t. So from here, our t is equals to cosine x. So we're going to put t back. So it becomes minus 2 over 3. Then the square root of cos cube x is the same thing as 3 over 2. Then plus 2 over 7 times the square root of cos 7x, then plus constant of integration. So this is the solution. This is the solution to the problem. Now we are going to be solving the third one in our next video. Okay, should I solve it here? Because it seems like we have elapsed the time. So thanks for watching. In our next video, we'll continue solving the problem. Do not forget to subscribe to this YouTube channel and share this video to your learning colleagues. Thank you. Bye bye.